Hello everyone and welcome to this lab. We will create a CodeStar project to manage a serverless application, and we will see how CodeStar can help us in the continuous delivery of our serverless application and managing our resources in this app. So let's head to the CodeStar console and start from there. On my AWS console, I'll go to CodeStar service, create a new project. These are the pre-configured templates that are available to you to start a project. You can filter here to focus on the technology and the deployment method that you are interested in. In our case, we are focused on Node.js and a Lambda function. And here you have three templates to choose from: a web application, a web service, or Alexa skill. So let's select a web application. I will name it CodeStar Lambda. Provisioning here the environment, it's still 0% complete. And after the code commit project is created for us, it will display the clone URL here, and it displays to you some information about how to connect your development tools to this new project. So let's give it a few minutes until it provisions the environment, and then we will walk through what has been created for us. 100% completed of provisioning the environment. So I will click on the skip link to get to the dashboard and start exploring what has been created. On the dashboard, as we have seen in the previous lab, you have your pipeline here. So you see that it's still picking up the initial project resources that have been created in code commit for us, and it will build and deploy this before we are able to access the endpoint of our application. Meanwhile, let's have a quick walkthrough of what has been created as part of this CodeStar project. Heading to the project section, and here you see the project resources. First thing is a CloudFormation template. With each template you select for your project, there is a pre-configured CloudFormation template picked up for you and executed to run the resources needed for this type of project. And then we have a code build, a code commit, and a code pipeline projects created for us. And it has created few IAM rules and a couple of S3 buckets. So the difference from the previous project is that there is no code deploy project created for us. So we only have a code commit, code build, and code pipeline projects created. Under the teams section, I am the only team member, but you can add a team member from here. Users have to be already configured and created in your account. So I can select a user, and I can select what would be the role of this user and add him. And this will behind the scene manage all of the IAM stuff that is needed for this user to have access to my project at the contributor role level. Back to the dashboard, we see that the source and the build stages are completed successfully, and now we are in the deploy stage of our serverless application. So let's give it a few seconds to finish the deployment, and then we'll have the endpoint of our application and start from there. So now the deployment stage is also successful, and we have the endpoint to our application up here. If we click this, it will take us to the application that has been just deployed. So now let's import this project into our Eclipse and see what has been generated for us. In my Eclipse, I have to have AWS Toolkit installed. This has been mentioned in the previous lab. If you don't like using Eclipse, you can still clone the code commit repositories that has been created for you and use any favorable tool to edit your files and push them to the code commit repository, and it will behave the same way. After installing the toolkit, you have this button for AWS Toolkit. I will click the small arrow and import a CodeStar project. This is already pre-configured with my account, so I should have the new project displayed right here, CodeStar Lambda. And my credentials already imported from the CSV file as we have seen in the previous lab. My master branch, finish. So here is the project that was created by default. You see that you have the index.js. This is our primary Lambda function code file, and the method get is the primary method for our Lambda function. And the only thing that this function does is reading the index.html file and create a body out of the contents of this file. So our real content is in index.html. But before we get there, let's see what has been created for us in the build spec. This is the code build specification file, and the template.yaml, this is our SAM file that will create our serverless resources. Let's first explore the build spec. This is the build spec file that has been generated by default. Under the build phase, it uses AWS S3 copy to copy the static artifacts, the HTML file and related resources like images, styles, and so on, all of these to this bucket. And then here it uses CloudFormation package to package our serverless application template. This is very similar to the exercise that we have done in our serverless application build in our code build section. And at the file section, it exports template export.json as the outputs of this file. So now let's make a change to our index.html and see how CodeStar behaves. So I just added this header to my index.html and I will save and commit my changes and see in action what happens in CodeStar. Commit and push. And this will push my changes. Let's get back to the CodeStar console. Give it a few seconds and the source stage will pick up the change and start downloading this revision. So now the source stage is picking up the changes from code commit. Now the revision source files have been downloaded from code commit and our build stage is picking up. So now the build stage is done and the deployment stage is picking up. So now the deployment stage is successful. It took nearly 7 minutes to roll out this update. Let's head to our endpoint and see the update. So now we see the header that we have added to our HTML file. So once again, the deployment is done through code pipeline combined with code build project, which is the same exercise that we have done in our previous labs. Let's have a quick look on the code pipeline created for this project and discuss few points in there. So from here, I'll go to the code pipeline. And this is very similar to the pipeline that we have created in our serverless application continuous delivery lab. You see here that you have a CloudFormation create change set followed by an execute change set to roll out our updates. However, we have categorized the changes we can make to a serverless application into two categories. The stack level updates includes actual changes to the resources, and the code level updates, which only the changes that we make to the code files, including any code resources attached to our project similar to the index.html file that we have in this project. And we mentioned that when you make code level changes, this will not be accepted as a CloudFormation change, and it will be rejected by CloudFormation, and it will generate an error if you try to roll out this update, because it doesn't include any resource level updates that CloudFormation understands. We also mentioned that there are some workarounds that you can rename your source code file every time you roll out an update, and this will be considered as a change to your serverless application stack. So this will generate a change set in CloudFormation and will be accepted, and when executed, it will update your stack with the new source code file. However, I thought that this is way over complicating the continuous delivery process of a serverless application. And this is exactly what happens in this project. Every time you roll out an update, it renames your source code file with an auto-generated name. And when it builds your SAM template, it uses this unique file name as the code URI of your Lambda function. So when it creates a change set with this SAM template, it is accepted by CloudFormation as a change set because you're actually referring a new source code file. So let's quickly have a look on the S3 bucket and what has been generated as the output of our build phase for this serverless application. Under the CodeStar Lambda pipeline, let's get to the code pipeline folder that's generated for the outputs, and let's pick up the latest one, download this file. As we have learned in our code pipeline section, this is a zip archive, so I'll just change it to .zip and unzip it and see what we have in there. This file includes the template the output template that we have defined to be the output of our code build phase. And as you see here, it uses a unique file name for the code URI of your Lambda function. So this is a workaround that works. You can use it for the continuous delivery of your serverless applications. However, I see that it's overcomplicated for a serverless architecture. And the way that we build our serverless applications is just through running AWS commands, either through S3 commands to upload some files to S3 bucket or CloudFormation commands to package and deploy our stack. In these cases, we can just execute these commands on our local machine or use the APIs or use triggers either from code commit or S3, link it to a Lambda function that can update function code or update our static resources in the S3 bucket selected. And this will take few seconds instead of the 7 minutes we have seen in rolling out an update to this serverless application. Beyond this concept, as we have mentioned in the previous lab, CodeStar is a great tool to jumpstart your project, and behind the scene it uses the same tools and services that we have learned through over the course. So whenever you need to tweak or tune one of these services, you can just head to the project directly and do any changes needed to manage your continuous delivery approach. And this concludes our walkthrough in CodeStar. Thanks for watching.